Hi friends, welcome to Coordinates, and today we want to proceed in our data structures and algorithms course. We want to see what is, of course, data structure, and can we implement another type of a data structures as at now. Yes, definitely, this is why we want to analyze a stack as a data structure in C++ or even in other programming languages, but for now we'll just understand it in C++. By definition, we can define a stack as simply a linear data structure that follows a particular order as it performs its operations. Now, a stack is one of data structures, of course, which a computer uses when implementing function calls. Some key words that we need to pay much attention to, of course, as we understand what a stack is simply the keyword a linear data structure. A linear data structure. The keyword linear is far different from the word non-linear. Hence, a stack is a linear data structure. Now, another key word that we need to pay much attention to is the word which denotes that a stack follows a particular order as it performs its operations. So if it follows a particular order, then what is that order? This is what we want to understand now. So the order of performing the operations by a stack is called LIFO, which is last in, first out. And again, at the same time, the order of performing its operation can be called that. If you forget the keyword LIFO, then you can refer to the keyword or acronym FILO, which stands in first in, last out. I mean, it's a swapping of thingies and anything related to that. So this is the actual order that a stack follows as it performs its operation. Now, let's try our level best to understand what LIFO is as an order that a stack uses to perform its operation. So we want now to explain what is last in, first out. Imagine if maybe you are storing certain content into a certain container. Let's say you are putting, is it the plates in a certain container? I mean, the plate that is first to be put into that container is the last plate to come out, because you can't, remove the plate on the bottom or as the first plate to be removed, whilst you even have the plate on the very top of that container. So that's what a stack actually means. That's what LIFO actually means. Last in, first out. And this is how we can implement. So if we are inserting certain things inside this container, I'm sure you can see that of course we have a container, a blue one definitely. If we are inserting certain content, this is the first thing. File 1 is the very first file to be inserted into the container. What if we insert another file? Let's say, okay, file 2 is another thing that is inserted into this container. Can we insert another file? Yes, definitely, because we have space in this container. We insert another file inside this container, which is file number 3. Let's insert the last one, which is file number 4. So this is what we are saying. Okay, we've inserted files inside this container, and this one was the first one, this one was the second one, third and fourth. Now, can we remove this file as the very first file to be removed? The answer is a no. Why? It's because how would we even remove this file? This file should be removed first, followed by this file, then this file, then this file will be removed. This is LIFO, last in, first out. This was the last file to be inserted, and it will come out as the very first file to come out. Last in, first out. And the actual operation when it comes to stacks, the operation that allows us to send content into a stack is the operation which we call a push operation. Hence the keyword push. We are pushing in files. File 1 we push in. File 2 we push in. Up to file number 4 we push in. Inserting data into a stack, into a container, sending value into a container, into a stack is what we call the push operation when it comes to stacks. Now let's proceed with the explanation of LIFO. You can tell that we still have the same container. Now we want to see, okay, we were inserting in the files now, and this was the first file to be inserted in, second, third, fourth. So when it comes now to getting out the content inside this container, this stack, how can the LIFO be applied? definitely if we are to remove, we can't remove file number 1 as the very first file, because it won't even come out. We have some files on the very top, we have plates on the very top. So if we are to remove them, file number 4 should come out. What file can we remove next? I mean, file number 3 can also be removed. What file can we remove again? File number 2 can come out. Is there another file that can come out? Yes, definitely. File number 1 can now definitely come out. And we even have an empty container, an empty stack. And the operation of removing elements inside a stack is what we call pop as an operation. The pop operation is the operation which denotes that yes, definitely an element can be removed from the stack, can be removed from the container. So this is what actually LIFO means: last in, first out. Let's proceed as we understand more operations when it comes to stacks here on data structures and algorithm with C++. So we've discussed, of course, what a push operation is. When we are inserting elements inside a stack, that is a push operation. And of course, from there we've also understood what a pop operation is. When we are removing elements from the stack, that is a pop operation. Now, what is definitely a pick as an operation when it comes to C++ and algorithm? A pick as an operation, we can define it and we can understand it in this way. This is simply the operation that returns the first element of the stack, or simply the element at the top of the stack, because we said for we to remove the elements, we should start removing from the very top. So the pick is simply the operation that can be performed on stacks, and this operations allows us to return the very top element of the stack. And that element, once it is returned, once we see it, it is not deleted from the stack. So this is what we can do. If we say, okay, I want to see the element in the stack, like the container we have, this is the stack. Okay, I want to see the elements on the very top. Definitely 4 will be printed out on the screen, but 4 won't be deleted from the stack and it will still remain in the stack, unlike pop, which definitely removes and deletes. Another type of an operation that we can understand based on the operations that we have so far is the top as an operation. Now, this operation also returns the element at the top of the stack container. It is similar to pick because it also doesn't delete the value that is inside the stack. Don't worry if you don't understand this theoretically, because in the next session we'll now have a practical implementation of what we are talking about. So also top is an operation. It works just like the pick as an operation. It returns the value on the very top of the stack, or the value that was inserted into the stack last, because it is last in, first out. But that element is also not deleted. If we are to do the practical, of course you can tell, if we say, okay, I want to see the top element of this stack, then 4 will be printed out on our console. That's if we are coding, and we will even know that yes, we've seen 4, but it is still in the stack. It has not been deleted from the stack. This is what top as an operation actually does. Other operations of the stack is simply the empty as an operation and the size as an operation. If we are to understand, we can of course understand these in this way. Empty as an operation, or is empty, it is used to check if the stack container is empty or not. So if we want to see, okay, do I have any element inside this stack, we need to use the key operation which is called empty. The syntax it follows is simply name of the stack, the name that you've given to that stack, dot empty, and you open the parenthesis without passing any parameter. It has no parameters passed to it, and it is a Boolean expression, meaning if we say, okay, let's say my stack is names, I say names.empty, the parameters I put a semicolon. If I contain the names inside that stack, if the stack is not empty, then I should see, okay, not empty. And since it is definitely a Boolean expression, then I expect to see, of course, the values 1 or 0, which is true or false, depending on the content that is inside that stack, depending whether the content is inside that stack or the content is not inside that stack. Another operation is simply the size operation. Now, this operation returns the total number of elements inside the stack. The actual syntax it follows is simply name of stack dot size and the parentheses. If you put a semicolon, let's say now the name of my stack is names dot size. If I have 4 names, then of course I will see 4 elements inside the stack. If I have 1 name, I will see 1 element inside the stack. So it returns the actual size of the elements that are inside our stack, the total number. So it returns the total number of elements inside the stack. So these are the basic operations that we can now talk about when it comes to the introduction as our first session in stacks. Now, how can we implement a stack? This is how we can implement a stack. A stack can be implemented using other 2 types of data structures. That could be an array or a linked list. It's nice that we've talked about arrays and linked lists. Hence, we can now, of course, proceed in our sessions to see how a stack can be implemented using an array or a linked list. If you want to understand what arrays are and linked lists in data structures, please check the description. There is a link that will send you to those sessions. So, a stack can be implemented, of course, using the arrays. At the same time, the same stack can be implemented using a linked list. You understand that arrays definitely hold data in a contiguous memory, whilst the linked list, of course, hold data in what we call nodes, and the nodes, they are respective to memory addresses. Hence, they are highly in associate to what we call pointers. Let's progress in our next session as we understand the practical implementation using a code of stacks using the arrays. Let's proceed. Please don't forget to subscribe, and you are on CodeNet.